So in the last section, we went ahead and started looking at plotting points in the coordinate plane, and I think based on the assignment here that we just got done looking at, really good understanding on this. So what we want to start trying to do is tie some of those ideas as to how does the coordinate plane tie into some of the geometry concepts we want to look at. So that being said here, 4.2 is titled Introduction to Coordinate Geometry. And what we're really looking at doing is forming some shapes in here, looking at names of polygons and areas. So my goal here, our job is to learn about the coordinate geometry that we're going to talk about. Identify polygons. Examples of polygons: triangle, quadrilateral, pentagon, hexagon. How many sides to a hexagon? 6. Okay. We're going to identify those polygons in the coordinate plane after we've plotted them. And then our job is to find the area of the polygons drawn on a coordinate plane. And the neat thing about the coordinate geometry is that each one of these squares is basically one square unit down here that I'm pointing at. We're really looking to find out how many square units are on the inside of that for some shapes that we're going to form here. So things we're going to need to know today are area formulas, specifically of 3 shapes. So if I had to say anything's really important right here, it's going to be in this vocab section. So taking a look here, this would be what's most important right here. You need to know this. Okay, so in that part right there, the first vocab part that I talk about is area of any kind of a rectangle. And what do I use for my formula over here, guys? A base times a height. So just as a quick example right here, guys, if I have a rectangle like this where my base is maybe, I don't know, 6 and my height's maybe 3, what are you going to do with the 6 and the 3 to find out how many square units occupy the inside of this rectangle? 6 times 3. So how many square units would be in there? 18 of them, right? Okay? You guys okay with that? All right. Then second formula we're looking at here would be the area of a triangle. It says to take the base times a and divide it by 2. Well, just a quick example here. If I had a triangle that maybe looked as something like this, let's just say maybe this base length down here is 6 again. And let's say the height of it again is 3. Okay? What are you going to do with the 6 and the 3 first? Times them, 18. But as it's a triangle, what are you going to do with your value then? Cut it in half. Yeah, anytime you deal with a triangle, that last step, take your base times height, but cut that value in half. All right, so what would you have up here as this example? 9. Okay. All right, and then my last formula right here is an area of any trapezoid that'll be helpful for us today. And honestly, guys, we may be able to get away with doing a trapezoid by breaking stuff down into triangles and rectangles. I'll talk about that in a little bit, but this one's kind of a tricky one. It says base 1 plus what?
Base 2.
Base 2. Well, let's identify what those are again. If this was my trapezoid, like so, in any trapezoid, the 2 sides that are bases are the sides that are
Longest.
well, not necessarily the longest, but
Straight one.
all the sides are straight. The 2 sides, what's the word?
Parallel.
Parallel, yeah. The 2 sides that are parallel here are the top and the bottom, right? Top and the bottom. Okay, so I would call this my base 1, and I would call this my base 2, right? Everybody got that? So if I called this a height of 12, or I'm sorry, a base of 12, and maybe this is a base of 10 right here. Whoa, what's going on here? Whoops, I got the wrong tool. If this is my base 1 right here, and base 2, you guys agree that those are the 2 sides that are parallel, right? Okay, let's just say base 1 is equal to a distance of 10, and base 2 is equal to a distance of 12, all right? Well, then the height is going to be the distance between those 2 parallel sides. So let's just say I've got a height here of maybe 6, okay? So by formula right here, it says take base 1 plus base 2 first. Then take that answer times my what? Height, and then the final part is to divide by 2. So let's just kind of calculate this real quickly. What would base 1 and base 2 add up to in this situation? So we're going to go 22 times what then, gang? Whatever that answer is, you want me to tell you? Well, it's 132. Very good. Right? And then we're going to take that answer by formula and do what in the end? Divide by 2. So how many square units would be on the inside of this trapezoid given those dimensions? Well, it would be, I think that's right, isn't it? 132 divided by 2? 66. All agree? All right. Questions about my areas at all? Questions about my areas at all? Formulas okay? We've kind of talked about them at various points this year, but as a refresher, are you okay with them? Okay, let's get to the heart of the matter. What are we really trying to accomplish today? I think example 1 will really explain what's going on here. We're going to look at a few examples like this. I think you're going to catch on to this nicely today. So, in example 1, what's it telling us to do first here, gang? Plot points. So I'm going to zoom up a little bit on this so I can make this bigger for you out there. Let's plot those points. Hey, I found a pretty cool. How many of you guys have used that Decimals calculator? Anybody? Might show you something today in your Chromebook. You might want to have that out here in a little bit, but it's pretty neat. I'll show it to you. Okay, kiddos, check it out. We need to plot those points right there. So the first point I'm asked to plot is what value, or what coordinate I should say. What coordinate am I looking to plot first? Negative 3, negative 2. How do you get to negative 3, negative 2, Jen?
Go left 3, down 2.
Left 3, down 2. You guys all agree that that would be left 3, down 2, maybe right there?
Yeah.
Okay. And then what's the next point I'm asked to plot?
4, negative 2.
4, negative 2. So how do I get there?
Go right 4 down.
Right 4 and down 2. I want you guys to plot C and D and tell me if you agree with the points that I plot when I do C and D.
I agree.
How many agree with what I have up there? All right. Now, once you've done that, your job, and I'm going to hand some rulers out so we can be really good at this today. I want you to go ahead and with a straight edge draw your figure. So I'll hand some rulers out over here, and I'll hand some out over here. Okay, so with your straight edge, I'll wait till everybody has one here.
It was.
With your straight edge, go ahead and connect the points in the order they were listed up there. And
Dang it, Mr. Carson.
was I in there? I'll calm down. Guys ready to rock and roll? Got it? Okay. Yeah, go ahead and draw your figures. I'll do the best to draw mine. My lines aren't perfectly straight, so forgive me. How am I doing?
Doing great.
And, oh, perfect. Okay, go ahead and draw that. So guys, realistically, what did we form there?
Square.
Might be a square. Specifically, it's a quadrilateral of some kind. It's a four-sided figure, right? Mariah, how do you know it's a square? Looks like a square.
It's parallel on all sides.
Okay. What else would be another defining characteristic of a square?
We can do a 90-degree.
All the angles are 90 degrees. I agree. Looks.
All the sides are the same length.
Sides are the same length. How do you know that, Brianna? I can just count, can't I? Let's count the bottom down here, guys. 1, 2, 3, 4, 5, 6. What's this length down here on the bottom? It's a length of 7, isn't it? Okay. How about my width, or my height, if you will? How many units here? 7. So guys, if I would go back up to my formulas that I had up here in the vocab part, which of these three, first, second, or third, which area formula would you apply to this? First one, would you? Okay. So here's the dealio. Down at the bottom here, it says name the polygon. Specifically, what kind of a polygon are you going to call it then? Well, it is a quadrilateral, but more specifically, you said it was a, yeah, I agree, it's a square. So put square right down here. Okay, so that's good. And then the area of the the area of the square, well, it's a rectangle, so what are you going to do here against your area? Yeah, isn't my area down here going to be like a rectangle? So my area is going to be 7 times 7, isn't it? Base times height. What are you going to get for a value there? 49. Okay, so what that means is this. Guys, for each one of these 1 squares down here, I'll just go ahead and highlight this one down here. I'm going to go ahead and highlight this one right here. That's 1 square unit right there, right? How many of these square units would it take to complete this figure up here, all in yellow? How many of these little squares are in the big square? What do we get for an answer? 49. There's 49 of those little ones in the big one. Okay, so if I would count them all inside of here, how many am I going to get that are shaded? 49. Okay, so I want you guys to get in the habit of writing down that this is 49. And I'm just going to abbreviate square units. Okay, so make sure you get in the habit of saying my area is 49 square units. Okay, 49 of those little squares inside of that big square. Okay, let's try another one. Let me know if you've got this down right here. All good? All good?
Go. Go.
Okay, page 2. Example 2 at the top. Here we go. First of all, how many vertices are there to example 2?
7.
There's 3 vertices, A, B, and C, right? So what's your guess on the shape that we're going to form here? Probably a triangle. Let's check it out. My first point is that looks like -3, 4. So describe how I would get there. Describe how I'm going to get there.
The left 3.
Left 3 and up 4, you said, Mariah?
Yeah.
Okay, right there. Whoops. Right here.
Yeah.
Let's zoom in again so I can get that. Next point.
-3 down 2.
Left 3 down 2, I agree. About here. And then finally,
Right 7.
looks like right 7 down 2. So here. So once you've got those 3 points plotted, go ahead with your straight edge and draw your shape. Okay. Make sure you've got that down here in a second. Top of page 2. All right, does anybody need more time forming the figure? Obviously, what kind of a shape or polygon do we get here, gang?
Triangle.
Get a triangle, so what am I going to put down here for name of the shape? I'm going to put triangle right here. Whoops. So I want to put triangle right here. All right. And then again, if I went back to the first page, which are the formulas, first, second, or third, am I going to use to try and find the number of square units within it? Second one, right? So what I would like to do is get up into this drawing here and say, you know what are the base and the height? Now keep in mind, a base and a height, how many degrees apart do they have to be of each other? So base is like the floor and the height's straight up, and that we assume an angle down at the bottom. 90. So you guys agree that right here in this triangle there'd be a 90-degree angle right here for base and height? Okay, so can I count my base length here?
That's 6 inches.
How many units long is my base? 10 units. How tall is the height?
6.
So 10 times 6, right? So I'm going to take 10 times 6. Am I done at that point for a triangle? Or do I have to do something else? Divide by 2. So for the area of this right here, I'm going to go 10 times 6 and divide that by 2 by area formula of a triangle, right? Okay. So what do you get? And I'm going to call this 30 what?
30 square units.
30 square units. Good. What do you guys think? So far, so good? Okay. Now, so far, the two shapes that we've looked at, they've been real nice. They've been really easy to see what the base and the height are. We really haven't had to do anything to try and figure that out. Now, guys, keep in mind, I can count left and right, and I can count up and down in terms of getting dimensions. The thing that we start running into problems is, what happens if our shape is not straight up and down or horizontal? What happens if it is maybe rotated or tilted a little bit, okay? So that's what I want to look at in this third example right down here. So what I might tell you to do is this. I'm going to draw a line right here. Oh, well, you know what I'm going to do? This is what I'll do. I'm going to say this one's really important. Okay. The points that I'm going to highlight here. No, yes, no. No, not the next one yet. This is a pretty important one right here, but it's going to be the one after this that I want to look at that's very important. All right? Let's do this third example right here. Oh, please fit, please fit. There we go. Go ahead and plot your points for this next one, okay? I'll do the same. Tell me if I've got my points correct. How'd I do? Okay, anybody else need more time drawing that? Okay. Kind of want to talk about this one a little bit in terms of finding the area. First of all, I know that's a trapezoid, don't I? Do you guys agree that that's a trapezoid? Okay. I'm going to apply the trapezoid formula to it, but I'm also going to kind of break this down and talk about the area in two different ways with this today, okay? First things first. Since we do know it's a trapezoid, let's go ahead and name this down on the bottom here quickly, okay? So I'm going to name this as a trapezoid. This is my trapezoid. Okay. Do we have a formula for a trapezoid? Base 1 plus base 2, then times the height, then times, or I'm sorry, then divided by 2, right? Okay. How about base 1 and base 2 in this? Anybody know what base 1, base 2 might be in this? What values, Lauren?
The top one.
Okay, how many units long is that if I count across?
I don't know. 14.
14 across, I agree. How about the bottom base? 8, okay. And again, remind me why the top and the bottom of this shape are the two bases of the trapezoid? Two sides that are parallel, okay? The side on the left or the side on the right, which one's going to be your height now? Side on the left because it's up and down, or it forms a 90-degree angle with the parallel side. So what's this height right here? Okay, so let's go ahead and find the area. We're going to go 14 plus 8 first, which is what value? 14 plus 8 first, which is what value? 22, we're going to take 22 times what? 22 times 5, So let me pull this up here quickly. So right up here, I'm going to do 22 times 5, right? It's 110, right? Okay. As it's a trapezoid, then what's your job in the final part? Divide by 2. So I'll divide this by 2, and what's our solution? 55. So in this last step right here of dividing by 2, yep, we get 55. We're going to call this 55 what, gang? I'm sorry, I missed it. What'd you say? 55 square units. Very good. I just abbreviate like this. Give me a show of hands. Somebody say, yeah, this is making sense here. Awesome. Okay? Okay, give me a show of hands if you didn't hear the question. Everybody heard it. Good. Okay. Are you guys up to speed with me? You got everything down that you need to have down at this point? Yes? No? Yes? All right. All right. Last page here, kiddos. Let's run through this. This top one, this is the one I really wanted to hit hard, okay? Put a star by this one. This one's pretty important. This one's pretty important right here, okay? All right. Why don't you guys take a second, go ahead and plot your points and draw your figure real quickly, okay? Plot your points, draw your figure. Okay, kiddos, first things first. Do I have my drawing correct up there? Okay. Boy, I got a question on the shape of this thing. You know what kind of shape this is? Guys, do you agree I go 7 and 5 this way? So this length right here would be the same as 7 and 5 this way. Wouldn't that length be the same?
Yeah.
7 and 5 this way. Wouldn't that length be the same?
Yeah.
7 and 5 this way. Wouldn't that length be the same? All sides are going to be the same then, right?
Yeah.
Got to be a square, right?
No.
If it is a square, what's going to be true of all my angles on the inside? If it's going to be a square, how many degrees are the angles? I'll check something here real quickly. I'm going to bring my protractor up here and measure this angle real quickly. Hang on a second. All right, I'm going to get these measuring devices over here. It says it's about 108 degrees, kiddos. Is that a 90-degree angle up there? No. So can this be a square? So what's another name for a four-sided figure where all sides are the same, but the interior angles are not all equal? Starts with an R. Rhombus, okay? It's the name of my third fish, rhombus. I have a fish named rhombus. I also have a fish named ferocious.
Mr. Person.
Yeah. Huh?
Why?
Why not? I have a fish named trapezoid. That's just because I weird. And you knew I weird already.
Yeah.
Okay, here we go. So we're gonna name the polygon. What kind of a polygon are we gonna call this, kiddos?
Rhombus.
Rhombus. So right down here, right, rhombus. Okay, this is the part you really need to pay attention to right here. We need to try and figure out a way to find the area. Okay? Well, we don't really have a formula for something that's tilted like this, because aren't my sides all of a sudden diagonal here instead of horizontal and vertical? Okay, here's what you can start looking at doing now, and this is very important, so you want to pay attention. Sometimes when you are trying to find the area of figures that are kind of irregular, in other words, the boundary lines aren't horizontal or vertical, you can start going to the inside of it and breaking it down into sections. And one thing that I think would be a really good idea here is this. I'm going to divide this maybe like so and so here. I'll put a cross in the middle of this, okay? Guys, by putting a cross in that, what does that do for dividing up that shape?
Makes it sort of.
Yeah.
Height.
Yeah, it gives me a height and it gives me a width here, but doesn't it divide it up into some certain shapes here?
Triangles.
Shape 1, shape 2, shape 3, shape 4. You guys see the 4 shapes I'm talking about there?
Yeah.
4 triangles, right? Furthermore, what's true about the shapes of the triangles right there? They're the same, aren't they? Okay. Question is this. Go ahead and break it down and find the area of each of those triangles individually.
Yes.
And try and add up each section to get a total area.
Yeah.
So go ahead and tell me, you guys tell me right now what the area of that section number 1 is going to be. Section number 1 going to look like to be. Section 1 is a triangle, right, guys?
35.
35.
Okay, but you got to take that 35 and cut it in half, yeah. So I'm going to look at just section 1. Just looking at section 1. I'll highlight section 1 here quickly. Guys, in my section 1 right here. Section 1. What's the base length of section 1? It's triangle. 7. So section 1. My area would be 7 times. How about a height of section 1? 5. What's that equal? 35. But as section 1 is a triangle, what do I have to divide that by now? Okay, what is 35 divided by 2?
17.5.
17.5 is what you get. So the area of section 1 is 17.5 square units. Now guys, check it out. In these triangles right here, like this red one right here, where your base was 7 and your height was 5, isn't the base 7 and the height 5 for all 4 of them?
Yeah.
So what's going to be true about all 4 triangles? Each of those sections is going to be an area of how much? 17.5. So what am I going to take this one section times, guys? Okay, so here we go. 17.5 times 4. 70 is correct. Right? 70 is correct. So what am I going to put in for area of the polygon? 70 square units, you bet. You guys okay with that? So right here, you want 70 square units. Okay, 70 square units. Very good. All right, I tell you what. I want you guys here in the last 10 minutes or so, I want you to go ahead and try this last one on your own. Get it plotted, get it named, try and find an area. When you've got an area that you think is correct, check with a neighbor around you.
Same as
Is it?
yes.
Oh.
Yeah, it's the same as the first one.
Let's see. See what you come up with. killer sound effects need to stop.
And Jacob.
Thank you.
Mia. Kyle. I don't have to move that. Lies.
Oh my gosh, it's the same thing again, isn't it? Okay. Crash shape again.
Square.
Square, what's your area?
49.
49. Okay. Questions about this at all? Anybody? Okay. So real quickly, gang, you